The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kīlauea and Mauna Loa update, and today something a little special. Dane is with us live down from the Pāhoa Community Center, and we'll be bringing you guys the USGS public meeting that's scheduled to start in about an hour at 6 p.m. Hawaiian time, and Dane will be covering that for us from down there, so we'll do a kind of abbreviated update on the front end, and then we'll switch over to Dane a little bit later on. Anything you want to share with us right now, Dane?
Yeah, just down here at the community center where USGS is starting to set up, and they have already shown some of a little bit about what they're going to broadcast today or presenting. We're going to be talking about these aerial electromagnetic surveys that are going to be going on over all of Kilauea. So that'll be going on at 6 p.m. tonight. We'll be live it here on Hawaii Tracker. So yeah, check us out, and we'll be on.
Right on. Mahalo for that, Dane. Yeah, so today I'll be manning the chat, and so let me know in the chat if you have any questions, and we'll try to do some discussion. I might be a little slower in the uptake picking your questions up from the chat. But we're going to let Dane go here for now, and he'll be on the chat also, but we won't keep the video going. And we will hear back from him a little later on. So mahalo, Dane. We'll talk to you soon. So with that intro out of the way here, let's start today with our Kilauea weekly summary. So here we have showing for you guys from the USGS HVO. This is the last 24 hours on a volcano. And this is what's been typical of the whole past week, right? We've had not a whole lot of activity on a volcano outside of the lava lake. The lava lake has been steady and persistently circulating. Lava's coming into it and moving around and going back under. But it's doing that at a pretty steady rate, and it's fluctuating up and down a little bit within that pit. That's this main pit right there in the middle. Let's see if I can get my marker on the screen. Let's see. Is right in there. That's that persistent lava lake. And you can see the West Vent Cone here and West Vent Pond and a couple other spots that are breaking open, glowing elsewhere in the crater floor. But really, for the most part, you don't see a whole lot of other action. This is within the last 24 hours here. So really, within the last 24 hours, volcanoes come out of a big deflation. This past week has had a large drop in the pressure on a volcano summit, similar to last week. Last week we had about a 5-day deflation, and this week about a 5-day deflation as well. So that means that as a consequence, we haven't seen these ooze-up flows in the perimeter, only the lava here in the middle on this main lava lake. That's the long and short of it. Viewing's still been good at of this lava lake area, but it's been more limited because now you have to be where you can see the lava lake from the east or from the south at Kīlauea. We'll talk about that here shortly as well. But that's the summary here. Looking at the past week, here's a whole last week from that KW camera. So you can see that pattern really holds. It's not just in the last 24 hours, but really see very little glow anywhere in the perimeter of this lava lake. Whereas it's constant circulating here in the middle. And we'll zoom into, there's a spot right over here. You see here's our southeast pit that is slightly connected, and we've seen the arch and all of that. But just outboard of that a little bit, along this line of crack that marks this old central crater crust, and where it's cracking and oozing out, we see a small flow leaking out really within the last 24 hours of right now. That seems to travel across on this right here. So keep your eye right there. There it goes. That's as exciting as I got outside of the lava lake really this past week. Still, the lava lake itself is spectacular, and we've seen before in the last couple of weeks when lava level drops down, you have a higher chance of seeing those walls collapse and falling in and having a big splash. It's like a few second moment in a long viewing opportunity, but still has been caught in the last couple of weeks. So that's exciting to think about what you might be able to see going down there. All right, so that's our KW camera. We'll switch over to our F1 camera. Once again from the USGS HVO. The F1 camera this past week did go through this little glitch where it lost its color sensitivity, right? It's kind of all off scale here. But it does give us the continuity and the overall pattern, right? We can see the lavas within that main pit right in there that whole time. We don't see any big lava flow emerging anywhere else. If anything, just down here, a little bit of extra heat over here in the West Vent complex as well, and so probably down here as well. Otherwise, what we really see is just this fluctuation in lava level. Lava level was higher about a week ago, dropped down pretty quickly, has stayed low most of the week, and coming back up just within the last 24 hours or so here at the end. Pretty similar story to last week, to be honest. Moving on, here is a current F1 view, and I'll just reload it to make sure we have the most recent view here. And you might notice there's not a whole lot of gap now between this lava and the edge of this lake. I'm looking at this dark purple and an orange, and how thick is this pink stripe in the middle right in there, and it's just not as thick as it was before. So lava level is coming up, and that's what we'll see in the monitoring signals here shortly as well. But as we continue to go through the imagery, this is the USGS V1 camera that's zoomed into that lava lake. This is probably the best view we have this week, since this is where all the action is concentrated. So you see that consistent circulation moving from the right side, right bottom of our view here, and it moves up and to the left, and it has 3 points where it sinks in, one being right here. And the second point it comes is it goes through this little gap to the southeast pit and sinks in there. And the last one is over here to the left side of the screen, slightly off screen. You see that northeast pit where it sinks as well. And that's the overall pattern. It hasn't changed in a long time. There's a tube that feeds it from that West Pond area. West Vent Pond area and the West Vent complex itself. Not a whole lot of change there. I can zoom it in because I think it's cool to look at these cliffs a little closer, and you can see the gap here between the southeast pond. You can see that gap that forms, and it crests over, and the lava level drops. And when lava level drops and stays down for for a period of time, it can actually form a small bench on a wall of the crater. So like a little lava ledge that forms at a slightly lower level. That was visible mostly during this past week. I pause it. Let me see if I can pull it back just a little bit here. Point out what I mean. Daytime view. Like right in there, you see there's a little extra ledge that goes around the crater where the lava was stable at that lower level. Then as it rises back up, the whole thing gets swarmed and drowned, and that's the end of that, right? You saw the hints of a little archway forming in here, or it gets submerged as well by the rising lava. Interesting stuff there to see. The close-up details of this persistent lava lake. And that's mostly what's been going on in Kilauea this past week. So looking on it now, here's a current view. You can see a much higher, closer to the rim, and over the last, well, this is current view. Okay, so here's a current view, and there it is, right up to the rim on the lip, right there. Better if I zoom it in. And here are the last 24 hours. Showing a little bit more of that changing, rising pattern there. All right, so there we are right now, and I'll just finish up the time lapses by pointing out, here's our S1 camera, or no, actually this is our B1 camera first. So now we're looking from the east side back across, that lava lake's over here in the west. And we're looking at the eastern crater floor. This is where we usually look for our ooze-ups and other kind of flows, but there hasn't been a whole lot of that. You see the few glowing spots from these hornitos that still exist across the crater floor. All around, right? So that's interesting to note. They're still glowing red, hot, but that doesn't mean anything apart from there's lava under the crust and a heat source down there. Otherwise, pretty quiet on this eastern edge, and that unfortunately means from the Uikahuna view on the north, viewing area in the north, probably not as great of views over this past week because of that lack of activity on the perimeter there. So we'll cover that here shortly. There's a B1 recently, and let's reload it and give you a present view. In present view. So there it is. You can see lots of these fuming hornitos still active down there. So the last thing I was going to finish with, as far as these cameras, are the here is the S1 camera, and you can see this camera's last date of update was July 1st at 9:47 p.m. So this camera is currently offline. We really don't have this view. Thankfully, the SGS mans all those other cameras, and we have all those other views to rely on. I'm sure they'll get to this repair as soon as they can. Mahalo, appreciate all of that from the USGS here. So I see some questions come in here. I see a $20 super chat from Chris Kiki. Mahalo, Chris. Appreciate that. He says, thank you, gentlemen, for all your time and knowledge to keep us informed. Mahalo. We're just happy that it's appreciated and supported. Yeah, we're just always happy to help. Let's see here, some other comments coming through here. Intrusions could happen when a lava lake rises 100 feet or more from Blue Moon. Yeah, it could be that as a lava lake is rising, the pressure will allow more intrusions to occur. One thing that's interesting, we'll look at the monitoring signals next, is whether there's enough pressure to put lava into the East Rift Zone at all, right? I mean, you imagine if that pressure down underground is enough, then it should be able to push into there to some degree as well. We're not quite seeing that yet, but maybe it's turning around, maybe not. We'll have to wait and see. And let's see, we got a question here. Let's see, I gotta look at a couple of different screens here to find the right name here. Let's see if I can do this successfully here. I'm trying to find... thanks for your patience here. Okay, so question is from Lisa on Facebook. Do you think that these periods of deflation and lower gas emissions might be a sign eruption is changing? Maybe. That's a pretty good segue into the monitoring signals next. So let's use that question to transition here. And let me get my monitor set up. And we will switch to Kilauea monitoring data. So here is monitoring data from Kilauea, starting with a GPS over the last year at the summit on the top. Okay, so you can see essentially this rising line means the distance between these two stations, north to south, and Kilauea summit are getting farther apart. Distance is increasing. And really, when you look into details, there's been a lot of variation here in a lot span of change here within the last couple months, right? So this probably has to do with these big deflations that we've seen in the past have had big effects on the GPS signal as well for short increments of time, whereas the long pattern stays heading upwards, right? So it still essentially seems to be heading upwards, and we can't really see past the noise at this point. Interesting to look at that. As far as a similar signal that's down here on Pāhoa across north and south across the rift zone, similar distance measurement, you can see that line is going down, the distance is getting shorter, meaning that rift zone is contracting, and it's been doing so, you can see pretty clearly since the beginning of this eruption back in September 21. So since then it's been straight down. You could say, looking closely here, oh, maybe it's flattening out a little bit, maybe something's starting to change. It could be, that could be. There have been other times where it seems like it might have been flattening out a little bit too, and then ultimately it wiggled its way back down to its longer term trend. So sometimes before all this was erupting, you can see at the tail of the last eruption, but you can see it was actually somewhat steady equilibrium in and out. But really since then it's been contracting, right? So the answer to the question that we just heard from Blue Moon is that apparently right now the magma does not seem to be going to the rift zone. If anything, it's just started going in here recently, maybe so, and you would imagine that at some point, as he predicts, when the magma pressure rises, you might see the signal turn around and you might see it start rising a little bit as well too. And that wouldn't be scary in and of itself. It would be more just showing the underground inner workings of it, right? It's a volcano, it's gonna pump magma through its veins, and that's what it does, right? So we just want to make sure we keep track as humans living up above it here. All right, so that's the GPS, and to really get at Lisa's questions here, and hope everyone else understands what she's talking about, we'll look at the tilt, but first getting there to the lava depth. Here's lava depth from the beginning of the eruption until now. It's been coming straight up. Here's these variations in the lava lake that we see. We start to see those again that correspond to deflation inflation events, right? So you can see that we had a period of time when we were measuring that on a lava lake earlier with big variations, and really what we were looking for at that point in time is like the top, right? If you look at the top of these, the highest point of this peak, that kept the trend going right there, right? Or if you looked at just the bottom kept the trend going as well too. You had to look at the longer term pattern rather than this up and down variation that happens in between, right? So when we look at what's happening now, then we can look at okay, well maybe it has flattened out a little bit to look at that trend, right? But maybe it's still rising slightly. It's possibly, you know, still in doubt. Oh. Back here. All right, so looking closer in, this is the last week. On top is a summit lava depth. This is in meters, right? So we started at 358 and a bit, and we ended at 363 and a bit. So you can see 5 meters and a bit. That's probably 18 feet-ish, something like that, of how much the lava lake has varied, right? From down to up, to back down, to back up again, kind of thing. And you can see it's matching the tilt pattern here in the bottom, right? So here's the last week, and you can see 5 days ago, the beginning of this deflation, and then just in the last 24 hours, it coming back up. Typical little bump here in between. So the signal was taking a whole week. It's hard to really judge it here. So really to have everyone else get to what I was talking about, here is the 1 month flat lava depth on top, and then a tilt here at the bottom. So here is what we're talking about. The two tilt signals earlier in a month were similar magnitude as far as how deep they went, right? But they were shorter in time, lasting maybe an order of a day or two. Here's another one of those, right? But really the last two have been these long ones, 5-day, almost a week-long events. And that does have a chance to disrupt the plumbing, so to speak, of the volcano as it comes up, right? But along those lines, we can look more closely here at our data. Our tilt is actually, looks like it's coming up. The top of this seems to be rising. It's still, if you look up here, it's probably still rising, right? So the hidden signal in here would not seem to indicate that this is about to stop. As far as lower gas emissions, let's scroll it down here. This is our gas emissions SO2 for the last month. And you can see down in here, here is all the gas emissions that have happened recently. 2 down here in a less than 1,000 range. And then the last, looks like 5 before that were under 1,500 or so, right? But it just so happens that these are falling during these big deflation events. and we didn't catch that gas measurement right in here in the middle. And so I think if you had a data point up here as well, you might see this data a little bit differently, right? And that's one of the challenges of the resolution and time of this gas data here. We'll talk about that here shortly in this week's Volcano Watch. But really, so I think that the gas is reflecting the deflation inflation events there and there, and seems to be the most obvious thing we've been seeing. Now, if it stays down, that'll be different. We'll have to wait and see, right? If the data point was here and the next one is down here as well, then that'll be different, and that could mean that it's a kind of a final burp rather than a continuing high rate. But really, what we're seeing is, as far as the tilt, you can see it's actually a rising signal there, and lava depth, you can see overall is a rising signal as well, despite all its fluctuations up and down. So we are looking for that signal, Lisa. We don't see it. Don't really see it yet. We'll see it someday, but I'm not convinced we're seeing it yet here. So that is the monitoring data through the gas here, right? And so we normally go from our gas to our hazards, but this week, as I just teased, we're going to switch to our Volcano Watch because it deals with exactly what we're talking about here. And so this week's Volcano Watch, which is posted on hawaiitracker.com if you'd like to go and read it on your own at some point. Picturing a plume. So this is written by the USGS HVO, of course. And then we have two images of degassing plumes here. The one on the left, visible by a standard visible light camera, mostly transparent with some blue-brown tones. And on the right, this is that same vantage point with a UV camera, and you can really see this cloud of SO2 that's actually transparent, right? And visible light actually shows up on the UV camera. So that is essentially what it comes down to, is using UV cameras to be able to track SO2. But beyond that, they can actually use those cameras to track SO2 at the same interval of time the camera is capturing pictures, right? So you basically have a better resolution in time. It's going to be more like our possibly our tilt graphs or something, where we have an actual calculation coming in every 15 minutes rather than just whenever they can go out and measure it. And it also doesn't have to measure just a single point. It can capture the entire frame, the whole field of view of the camera, right? And they can actually, with different wind conditions or different multiple points of fume, perhaps, be able to image that kind of thing as well, right? So they're talking about deploying one of these at Kilauea Summit, and possibly one will be a mobile or eventually end up at Mauna Loa Summit. And what makes this a little extra interesting is that these are not like the UV cameras used on Kilauea before that have been used by Patricia Nadeau and other scientists there. These ones that they're using now are essentially based on Raspberry Pi technology. So the Pi cams, as they're calling them, are going to be another tool in a monitoring kit. So this is kind of a new iteration. That means you can make them pretty small. You can make more of them and deploy them in more places, and that means you get better data that way. So that's this week's Volcano Watch. I will not go into it any further than that because I do have to finish before that meeting starts, so I better keep moving here, right? And seeing as we're talking about gas, we will switch to our VOG forecast and volcanic hazard summary. So here's the latest summary from the VOG mapping project from UH Manoa. CMAP, weather.hawaii.edu. And you can see, even though we have a lower emission source, we're using 700 tons per day of output here. It's still moving down here to southwest, typical trade wind patterns for the summertime. It still consistently and chronically affects certain areas. So much of the island is actually a little bit better because there's less coming out to start with, and the winds are better. But there are some areas that are still getting it, and so we'll show you that here. First, Purple Air, citizen science initiative with monitors in people's houses. You can see here it's in the green, just about all these areas at present right now, right? But if I click down here, where am I at? Kahuku. And you can see that we've crossed into the yellow several points in the last week here. It still kind of comes through and spikes through depending on the wind direction on the day. And if we look here at the national park. The national park, most of the viewing sites are all in the green, right? Most of the time. And if we go back to the history here, when you scroll back in time, we'll notice that earlier this morning there was a period of moderate yellow advisory level that occurred just before 5 a.m., right? So you're looking at, it'll tell me here exactly what time, but if we go into the advisory by site here, then we can see the history a little more clearly. So we're looking for anything that's not green. So Kahuku had particulate matter during the day when the wind was blowing in that direction. And if we scroll down, we can see Jagger Museum had particulate matter as well for a couple intervals here prior to 5 a.m. So it can be foggy in the morning with slack winds, that kind of thing. And that's typically how it is, right? But still not too bad when a total amounts coming out are fairly low. All right, we'll switch to lava viewing now. We don't have a whole lot of detail extra on that today. We're gonna keep it short. But we've typically been pointing out 3 viewing areas. Kanakakoi is still the one that requires the longest walk, but gets the most direct, closest view. You can see a lot of the other part of the crater as well from here. But if you're looking at just the lava lake itself, you can also see it, besides Kanakakoi, from Kupina'ipali, also known as Waldron's Ledge, accessible from the main park visitor center and around the volcano house on the old earthquake trail. So from there, you can also see the lava lake directly. And of course, it's pretty small from these great distances, so it's always worth bringing something to magnify, right? A big camera, binoculars, telescope, that kind of thing. And the views that you would see are basically looking in at the variations on this lava pit right here. And this is what's been active and the star of the show, essentially, the whole last week being the only center of activity there. So as always, you want to check the National Park website. Right? They always have a section with alerts up in effect on top that are current, right? So you can always check what's going on a particular day you're going to visit. And then down here, that very first thing, eruption viewing, you can click on that. You can go through and it'll give you conditions and it'll show you links to the webcams, the air effects, right? The viewing areas, all marked off right here. And et cetera, how to get there, what to bring, all of that. So check the park website if you're planning to visit. Right, so with that said, we will switch quickly here to continue our monitoring with looking at earthquakes. So earthquakes on the screen next. So on Kilauea, in this map area shown right here, right, over the last week, earthquakes have been pretty normal, right, coming in at the typical rate we've seen over the last month, right, close to our long-term average of about 30 per day. So that's all normal. Even when it comes up a little bit, it's nothing to be alarmed about when it's just something like that. Over the last week, here is the map of them. So you can see there was one event here under the south flank and mostly elsewhere under Pāhoa, and a little bit under the summit. Right? Actually, interesting, the locations of the events. Similar areas as we've seen recently, but nothing abnormal. You notice that there is a cluster of deeper events still happening here offshore, southeast of the volcano. Nothing alarming, just that adjustment from those magma sources deep down. All right, looking back at the last month, here it is, a little bit more populated. You see the south flank movement and adjustment a little more easily, the summit activity a little more easily, and Pāhoa is staring you right in the face, hard to miss there. That's where most of the numbers are coming from. That actual cluster in Pāhoa and the zone above it are disconnected with solid rock in between, right? So bigger, right? So deep Pāhoa earthquakes occurring, gap with no earthquakes, and then shallow earthquakes happening above it, right? So this means there's no magma coming up through there or anything like that. It's just pressurizing below, and it's because it's near the hotspot and all of that. And we'll know a lot more after the summer's field session from the USGS, and so we will pick up on that at that point in time, right? For now, really no cause for alarm and nothing unusual with earthquakes going on. When we zoom it out a little bit, here's the whole island of Hawaii. There's still a couple of earthquakes over here on the northwest side of Mauna Kea going on. There is a Pāhoa cluster, right? And the almost almost 3 different clusters there. That's the one closer to Mauna Loa, and then there's one closer to Kīlauea, and then there's one closer to Loihi a little bit over here, right? And so there have been, I've heard a speculation that perhaps maybe that's different pathways. We'll have to wait for some publication to give us some better details, right? And hopefully that survey this summer as well. So we'll keep noticing that detail. It's more and more apparent every time we look. Here on Mauna Loa, you can see more activity at the summit, upper southwest rift, northwest quadrant. These are all the typical areas we see when a volcano is inflating and magma is coming into it, which it has been doing so without really straining it or pushing it towards any breaking point. That's the story in Mauna Loa. We've seen a little more earthquakes now than in recent weeks. A little more on the flanks visible here and here, right? If we let's switch our tag here because we're really transitioning from our earthquakes to Mauna Loa here, and looking at earthquake rates on Mauna Loa, you can see that in this is the last year. If I zoom into the last couple months here, you can see that it really has come up in the last month, but it's come up to really average levels, right? It really was abnormally low. This is all average in here. Here's the last flurry that we had February of earlier this year, and even that was just a minor little blip with not a whole lot of other movement. So if this wasn't alarming, then certainly this is not alarming as well. Still, she's filling with lava. It's just with magma. It's just a matter of time before the lava comes out. We still hope it's later than sooner. Looking at GPS, north and south across Mauna Loa, you see long-term over the last year, also getting further apart, so it's still spreading. A little more slowly here recently with some adjustments happening in between, right? But nothing drastic, nothing dramatic. There's no clear, obvious, huge change imminent. So still quiet Mauna Loa, maybe slightly more active than before, but kind of back to this normal amount, which is sometimes shocking how much is normal in Mauna Loa, but that is how it usually goes. So that is Mauna Loa. Just to mention, mahalo to the USGS HVO, right? This is all information coming from them. Here is their official Mauna Loa update issued today. Not erupting, still at alert level advisory, aviation color yellow. Seismicity above background levels, but not changed significantly, and other streams showing no significant changes. All right. So with that, let's see if I can catch up on a few questions over here. Let me come into, let's see here. I see, we have a super chat from Yan Zhao. Mahalo, Yan Zhao. Hopefully I said your name close enough. Question: can this kind of volcano become one like Krakatoa? I'm trying to learn. So mahalo. Definitely appreciate you trying to learn and appreciate your contribution. Thanks for that. So there basically are different kinds of magma at different volcanoes, and the magma at Kilauea is different from the one you have at Krakatoa. So Krakatoa is not the kind of scenario we expect here, right? So this volcano is not going to become one like Krakatoa. However, depending on what you think of Krakatoa is actually like, there could be some similarities. For example, we know that Kilauea can have explosions that put ash high up into the atmosphere, and Mauna Loa can as well. And these explosions can throw big rocks out of the crater that can actually travel several kilometers and impact everything that's in the area surrounding there. So that's certainly possible as well. But the actual mechanism of how and how big it can get and how far it can go, that's a little bit different, right? So Krakatoa is an island volcano as well, right? So similarities in the fact that when its flanks can move, it can generate tsunami, right? That's something that Hawaii can do as well, even if the magma is a little bit different inside the volcano. If the volcano can actually shift or cause an earthquake, then you can have tsunami that can be similar. So it can be some similarities, but also some big differences. And I hope that's a good enough quick answer, first take for you. So mahalo once again. All right, so and scrolling back here, I see another super chat from Gary Bryan for $35. Mahalo, Gary. Thank you for being a long-term supporter. Thanks, Phil and Dane, for all your work producing these updates. Mahalo, Gary, for being such a loyal and such a generous supporter for that. All right, let's come back up here. I see Two Pineapples is on. Aloha, you guys. Two Pineapples had an epic backpacking trip to Mauna Loa Summit, so we'll cover that some more next week probably, because this week I'm really on a time schedule here to be done before that meeting starts at 6 p.m. here. So mahalo. I did see you guys sent some stuff, but we'll have to fold it in next week here. All right. So let's see. Any other questions at this moment? South flank isn't inhabited. The south flank is essentially the whole south part of Kilauea. So most of Lower Puna involves the south flank. Then that part is inhabited. Kalapana, you think of Kalapana area, but the area west of Kalapana, because it's a national park, is not inhabited, we should say, anymore, because there is a history of it having been inhabited in the past before it was a national park. So, earthquakes are pretty normal, I should say there, right? So it's more about how much is it going to move at a time, right? But even still. All right, well, I see Dana answered that already a little bit up there. So, all right, so there are some questions. Let's see here what I have to put on my screen next. It is going to be our community corner. So let me switch to that here real quick. So here is a flyer for what's going on today down there that Dane is involved in. A helicopter survey over Kīlauea to collect geophysical data. This is down at Pāhoa Community Center. 6 to 6:30 is a presentation and Q&A talk story until 7:30. So we'll see how long we can keep the stream going for you guys. Saw a couple little hiccups in the quality earlier, so we'll see what we can do as far as that. But otherwise, this is a talk about the survey occurring. Let's show you guys here. Oh, got it. Well, I'll show you guys that in a few minutes. They're basically flying lines across the park down to Kalapana area, more or less, and that's what this is going to be about. Imaging that upper 2,000 feet of magmatic structure, fault systems, and groundwater pathways on Kilauea. So we'll have more on that coming up shortly. That's tonight. Next week on Tuesday, July 12th, 4:30 to 7:30 p.m. Doors open at 3:30 p.m. if you're going to go and check out all the tables. There will be county infrastructure updates, Pohuiki boat ramp updates, community-led projects and volunteer opportunities, the revitalized Pohuiki restoration roadmap, right? This is talking about the park area and just the whole area in general, beyond just the boat ramp, right? The boat ramp's just where the boats get in and out, but there's a lot more to Pohuiki than that. The resource row, right? There'll be all kinds of resources. If you need any assistance, or if you would like to just make use of all the wonderful work, nonprofit work being done here in Lower Puna. There'll be that. Food trucks, Keiki Craft Station, event is free. And there's actually maybe I shouldn't do this, right? Dane is warning us of the risk of QR codes all the time, but there is a QR code here to register or visit rp5@eventbrite.com right there. And so that's coming up on Tuesday. And then one last thing in our community corner is requests from USGS and Hawaii Volcanoes National Park for public input on the environmental assessment for the recovery project. And so we've covered this similarly before as far as what plans were under consideration, and we've gone through all that. And so they've selected a plan, and they're going to hope to break ground soon. And they're conducting an environmental assessment. So the long and short of it is that there is a comment period open now, open July 1st, closes July 31st. And there is a website where you can provide input. There will also be virtual public meetings occurring July 21st at noon and again at 6 p.m., right? So we will probably cover this in more detail a little closer to that date. But I do want to mention that is up there. It's out there. It's on the USGS site. We'll post it soon too, I'm sure. But this is essentially for deconstructing the Jagger Museum, repairing the bathrooms, restoring access to the overlook and connecting the trails further over, replacing the water tanks, constructing new facilities by KMC, constructing a new visitor center, parking lots, all that stuff that goes with it there. Right, so preferred method is online here at parkplanning.nps.gov/HAVO disaster recovery. That's where you can go and find that, but there's also other ways as well. So we'll cover this in more detail, but those of you guys for this is a big deal, then you can be in a know already and start preparing your comments. All right, so one more thing to do is to say some mahalos, right? So as usual, mahalo to our long-term supporter, Kilauea's Bar and Grill. 2 locations, one out in Pāhoa and the other one in Orchidland. And I believe Thursday nights, as usual, Ikeka Marzo probably playing down there. Make reservations as usual, of course. And Danny obviously is the normal presenter of Kilauea's here, so I maybe will not try to rival his awesome delivery and leave it at that. Mahalo Kilauea's for your long-term support. All right, let me see here what else is on the different chats. Yeah, okay, so Dana is saying here as well, USGS is going to have Q&A, so if we have questions for the USGS on that AEM survey, Aerial Electromagnetic Survey, we can submit them for you guys as well. So we will do that shortly. Let me just, I wanted to do one. So first of all, let's see if there's any questions. Are there any questions coming up here? And I'm looking around. I don't see. Oh, here's a question. Question from Maris. Are there now areas being built that are on lava from the 1980s and 1990s? I think that was not a question. It was actually a statement. Yeah. So yeah, there are mahalo Marin for your input there. People are building on that now a little bit older lava, right, in that area of the South Flank as well. So comment from Blue Moon about those explosions. Boulder took a life in a 24 explosive eruption. Yeah, that's true. Photographer got hit by a boulder, and that was the fatality there. Not nearly as bad as 1790, right? 1790, there are reports of up to, well, the numbers vary, 80, 800 Hawaiian warriors possibly killed during an explosive eruption of 1790, right? So that's kind of the big example there, right? And Tiffany's asking, how's the lava lake? Hi, Tiffany. Good to see you. Lava Lake is still steady, and it's been a main attraction the last week, as no real big ooze-ups elsewhere around the crater because of the long deflation. So long deflation, Lava Lake's still been circulating, still churning, everything's still going normal, and looks like it's still there, still active. So let's see here. I don't know if I got all these questions. Yeah. So okay. So yeah, this survey that we're discussing today, right, is a part of this topic we discussed in the past, Volcano Watch from May 26 here, where we talked about them dangling this big loop from the helicopter. That's what we're talking about today. That combined with MT mapping locations, which we covered here as well. So we'll have all this available to discuss afterwards if needed. There was one last thing that I kind of wanted to do here before we switch gears completely, and that is to just touch base on 2018 a little bit, right? Because it is still a time of reflection and thinking back to 2018, right? So what I thought I would do today is, in order to actually be able to prepare with Dane a little bit for the upcoming meeting here, is I'm going to play you guys 5-minute video from Andrew Hara from that eruption, right? So this is titled 100 Days 2018 Kilauea Eruption. Andrew Hara, who was a Hawaii Tracker contributor, and has done all kinds of other amazing work before and since, of course. So for now, I will transition to 100 Days of Kilauea Eruption. All right, so there goes. All right, you guys. So mahalo to Andrew Hara. Pretty amazing compilation, 2018. Interesting, we talk so much about it, but really there's so many emotions that come just from able to watch and see and listen and all of that. So mahalo for that. So, all right, we're getting close to time for that meeting to be starting down in Pāhoa. So let me bear with me here while we get our views switched around a little bit here. So, all right, looks like Dane has got the camera lined up there towards the wall where the presentation is going to be, perhaps. Looks like. And let's see if I can get him to say something for us. Let's see if I can get the message to him to test out this microphone.
Test.
All right, we can hear him. Yeah, sounds good. All right, so if you want to add anything, go ahead. Otherwise, let's wait for the USGS to get started here. And I suppose I could, let's see here.
Yep, everybody's kind of still setting up over here, getting everything ready. Probably see about that 6 p.m. start, but it might be a little bit late.
Okay. All right. Mahalo for that, Dane. So
yeah, I'm sorry I cannot hear anything that Philip is saying. But yeah, I'll be here ready for whenever they do get it going.
All right, mahalo, Dane. So what we'll do, let me do this. Let me transition here to, let's put this on the screen here. This is the announcement for today's talk. Meeting on a helicopter survey over unpopulated parts of Kilauea. And that's what's coming up here. I showed you guys a fly already. Here's an image of a helicopter pulling one of these big wires below it, right? That's what's measuring the electromagnetic field as they're flying it over, right? They gotta try to keep it at a fairly level elevation over the ground, right? So they gotta stay steady over the ground and trees and rooftops like that. We don't want to be doing a whole lot of bouncing around. And the oval is 50 by 80 feet, oval shaped, and it's suspended 100 feet below the helicopter and is flying 115 to 165 feet above the ground or treetops. So it's not going to fly over any residential areas or other regions excluded by FAA regulations or national park policies. Because they understand the noise is disruptive, they greatly appreciate affected residents' patience and understanding as they collect this important data. So the tentative schedule actually began yesterday over in a west area near Pāhoa, July 6 for flight lines 1 and 2. Right, so let me pull this up. Right, here's a map of the flight lines. So 1 and 2 are over here down in this very southwest corner by Pāhoa. That's probably just happened yesterday. And today, July 7th, 3 and 4. So that would have been these two over here. So they're already marching away over from Kau over towards the national park. Then they'll kind of march their way across, and they'll get as far as the eastern edge of the national park right in here, right around Kalapana. So there are multiple surveys going on. This AEM survey is one that's just going to go as far as Kalapana here. Right. Right. So you can see 5 and 6 July 8th, 7 and 8 July 9th. No flights on the 10th. On the 11th, there'll be 9, including Kilauea caldera, with USGS scientists stationed on the rim of the caldera at Wahine Kapu, Steaming Bluff, and overlook near Kankakoi to answer craters, and then also 10. So on July 12th, it'll be 11 and 12. On July 13th, it'll be 13 and 14. On the 14th, 15 and 16. You can see marching away across, and they'll basically be in Kalapana around July 14th and 15th. It's easternmost area right over here. So that is the map that they've put out. They've also put out this media alert, right? State news release, low-flying helicopter survey to reveal Kilauea's inner. And this is because of FAA regulations. They're announcing this low-level airborne project, and we're trying to do our part in assisting local communities of what's going on here, right? One interesting aspect of this is that there are other communities besides Lower Puna that are being affected, namely Volcano Community, Pahala Community, and recognize that it's pretty far from Pahala and Volcano to Pāhoa. So to make this content available for you guys from the USGS, we thought we would also come over here. And I see maybe some action going on over here on Dane's end, but I suppose until he comes on, we'll just wait. Right, so let's see, it looks like there's still waiting over here. Okay, so while I'm waiting, I did see some questions from Jim Pushaw. I hope I'm saying it right. Mahalo, Jim, for your persistence and asking your questions, getting your questions here. So let me pull that back up here as far as what you're talking about. You talked about the 2 groups of earthquakes. All the way back over here. So, all right, yeah, 2 groups of earthquakes, maybe 3 visible today, Jim. And we haven't heard anything definitive, but the speculation that this cluster maybe is more connected to Mauna Loa's feeding system, and this cluster maybe more connected to Kilauea's feeder system, and this cluster possibly more connected to Loihi. That's the best I can do as far as an answer, Jim. I haven't seen anything actually published about that. Just talking story with guys like USGS. That's the one idea that has come up that they've shared. So I think when we see the results of the survey, right, since I have a little time, we jump all the way to over here. They are using these portable seismometers all over Pahala to image that area this summer. And so we should know a lot more about these various clusters and the whole structure that's involved beneath them after that data is published. Right, collected this summer, it'll probably be a year or 2 or somewhere in that time frame like that before you actually see them. So that was his first question a couple weeks ago. Mahalo for that. That's definitely right. And then Jim also mentions that he emailed the USGS to ask how deep the existing lava lake was when the eruption began. And so 732 feet. You add that to that 394 he said as the most recent update he has. But if I look today here at Kilauea, the most recent number, yeah, 394 still. That makes the total depth 1126, right? That's the total fill of lava in the crater if you measure all the way to the previous collapse bottom, right? So really cool. If you take that lava laser distance measurement, you can get a little bit more precise than that, but that's still really amazing, right? Yeah, it's we mentioned when it hit over 1,000 feet altogether. Now it's going on 1,200 feet, so pretty incredible for sure. So mahalo for your input, Jim. Appreciate that. It looks like they're still setting up down there in Pāhoa. Looks like we're maybe getting a screen coming in here. All right, sounds like they're about ready. Here we go.
All right, well, I'm going to get started because there's a bunch of people online. Yeah. Yep. All right. Yeah. Okay, so make sure I know how to do this. Katie, does this advance the slides or anything? There's the pointer. There's the pointer. All right, that was fine. Just do it because it's a pretty short audience. Okay. Well, thank you to everybody online and who's here. I guess you were supposed to talk, but we're going to be talking about a helicopter survey over Kilauea, and it is funded by the Disaster Relief Act of 2019, which, Ken, maybe you can say something about that. I should introduce myself too.
Yeah. Aloha, everybody. I'm Dr. Ken Hahn. I'm the current scientist in charge of the Hawaiian Volcano Observatory. And today we're going to have a presentation about one piece of some of the research and hazards mitigation that we're doing that is being funded by the Disaster Relief Act of 2019 that was a direct result of the 2018 eruption in Lower Puna. So this particular survey in here is for us to get a better idea of what the current magmatic plumbing system is of the Lower East Rift Zone and all the way actually back up to the summit area and how it connects to the caldera, because we know that there was a connection in 2018 between the eruption and the caldera and emptying a magma chamber. And so this is one piece of kind of advanced scientific research that we're doing to try and image underground what is going on. So Dr. Carol Finn, she is from the U.S. Geological Survey in Denver, and she's a geophysicist that has literally worked everywhere in the world, as well and in some other places in the U.S., national parks and things, and also is an expert on imaging things beneath the ice caps in Antarctica. So she's done a lot of really cool stuff. So she's going to tell you how that she is using aeromagnetics and resistivity of the rocks to determine where there are pathways for magma and where there might be molten magma. There you go.
Thank you. All right. Okay, so now we'll really start. Next slide. So one of the things that we want to understand is, well, a lot more about the 2018 eruption and ways to understand the whole plumbing system for magma for Kilauea. So we have a bunch of questions, including how much magma is present in the upper 700 meters or so 2,300 feet of Kilauea. Where are the shallow pathways for magma and groundwater? And how has the magma system changed since 1978? The reason we picked 1978 is that there were geophysical surveys flown in that time period. And then where's the boundary between freshwater and saltwater? So we know that there's saltwater along the coast, and so we want to see those boundaries. Next slide. And so to answer some of these questions, we want to look below the surface with helicopter, electromagnetic, and magnetic data, which I will talk about in more detail. And electrical resistivity models can detect fresh groundwater, magma, seawater, and faults. And magnetic susceptibility models, which you get from magnetic data, show magma conduits and faults, and they can help with the mapping of lava flows and intrusions, which are basically internal lava. What tools do we use? This is a system from a company called SkyTem, and it has a helicopter and has a big loop with a transmitter coil, a generator, and the TEM stands for time domain electromagnetic receiver. There's pitch and roll sensors and laser altimeters to make sure you can measure what the position of the loop is. We have GPS and a magnetometer. So how does this work? So the generator powers an electric current in the loop, which is the transmitter coil. And the magnetic field induces currents in the ground. And the currents are stronger in magma and water than in lava. And these currents, in turn, generate a secondary magnetic field, which is shown on those black lines there. And the properties of that secondary magnetic field tell us something about the resistivity of the ground. And the other instrument, called the magnetometer, just measures the present Earth field direction. And different rocks, some rocks are magnetic and some rocks are not. In a lot of places, there's a very big difference between volcanic rocks, which are magnetic, and sedimentary rocks, which are not, but you have mostly volcanic rocks here. But there are different variations that we can see. And that can tell us the difference between those and dikes, which are basically magma conduits that can be old ones, so they're frozen, or new ones, and also can image faults. Next one. So for the electromagnetic system, the difference is between, like, if it's a solid lava, it's a very weak signal, and you get a strong signal from magma and water. You can think of like the solid volcanic rocks as being like an insulator, and the magma and water as being a conductor, like a wire. Next. So what does the system look like when it's flying? Can you hit the, I think if you hit forward. Let's see. Does it come up? I usually have it, unless I didn't bring up the video one. Okay. Okay. So this is a video that Katie took yesterday at Kapapala Ranch that shows the helicopter with the loop flying. So that's what it will look like if you see it. Okay. I don't think we need, let me see if I have the other, I have another video. Let's see if I can do it. Okay, so this is the SkyTem system. Oops, it's not going. We have to shut down the, sorry. So this is a SkyTem system on another volcano called Reunion Island in the Indian Ocean. And it just shows it's very similar to Hawaii in terms of the rocks and the terrain. And the helicopter is flying 80 kilometers per hour on a prescribed path, which is programmed into the helicopter. So the pilot just, there's a picture, you can see that screen on the left, and the pilot just follows the directions of that. This is different in the, they have a second person in the helicopter. We'll only have the pilot and the instruments, and you can see how steep that is. So you can stop that. It just gives you a sense of what that looks like. Okay, so when are we flying? Where are we flying? So the flights will be occurring. Today we had a test flight, and hopefully we'll start flying the survey tomorrow and for several weeks. And the helicopter flies 3 to 7 hours per day. During the day, flights are about 1 hour and 50 minutes. We usually try to get, 2 flights? It'd be nice to get 4. And generally between 9 a.m. and 4 p.m. The loop is 115 to 165 feet above the ground or the top of the trees. The helicopter is about 230 to 280 feet above the ground. So these yellow lines here are the flight paths, and the helicopter flies along these paths. It's kind of like mowing the lawn, going back and forth. And we're going to start the survey in the west near Pāhoa and go to the northeast. So the lower Puna flights will be toward the end of the survey period. You can see that there are holes in the flight lines. In the park, there are very populated areas. And over to the northeast and the lower Puna area, a lot of the holes are over residential areas. So we don't fly over. FAA regulations prohibit people with anything dangling below the helicopter to fly over houses at all. So the residential areas are completely blocked out. People who live in remote areas, the helicopter can easily go around the buildings. They won't fly over them. They don't fly over cars either. The helicopter can stop. Next. So SkyTem has flown surveys safely all over the world. This is once again a picture from Reunion Island. How many years has SkyTem been? 20, 30? Yeah, so nearly 20 years and flown a lot of places. I've SkyTem their surveys for me at Mount St. Helens and in Alaska, and it's operated safely all over the world. It's had no accidents or environmental damage. The loop has redundant systems to secure it to the helicopter, and the loop has never fallen off. SkyTem contracts local companies to fly these surveys, and they make sure that the pilots are selected for their experience with flying long lines, and also here of flying locally over Kilauea. Next. How safe is the system? Well, this graph on the left just shows sort of the strength of the magnetic field generated by the system over frequency. And what it tells you, that black line is what's showing the SkyTem system. And what it shows you is that the amount of magnetic exposure is like you get from standing one foot away from a toaster. And not as much as you get from a mixer. And it's well below, it's 100th of the accepted general public exposure across all frequencies. So it's not going to endanger anyone's health or animals' health, and has been flown all over the world without any adverse health effects. The magnetometer itself doesn't transmit any energy. It just measures the field. So it doesn't pose any health risk either. Next. So how will this survey impact residents? Flights will not go over subdivisions, as I mentioned, and individual homes in less populated areas. The flight paths will, in general, be only flown once. If there's some data problems, we might have to refly part of a line, but in my experience, we don't do that very often. Nobody likes to do that. So those flight paths, you only see it once. As I mentioned, helicopters will not fly over people or cars. Residents, however, may hear some of the helicopter noise or see the helicopter with a loop. And as I mentioned, no risk to health or safety. And this technology is the same as what you use for wireless chargers for your phone, or for an induction stove, or a metal detector. So it's familiar technology. So has this kind of data been collected before here? Well, yes. This is a picture of a magnetic anomaly map for Kilauea that was flown in 1978. The red colors are indicating places that are more magnetic than the surrounding rocks. And it's really looking at different kinds of lava flows and intrusions, which are, as I mentioned, lava that doesn't come to the surface. But the interesting thing in this map is really this big red line right here, and going from the summit, Pu'uo, and down to here. And those are dikes, which are conduits for magma. So this is from 1978, so it's before these current eruptions. So one of the things we'll be able to do is compare the new data to this to see if there's any change. And these data sense to thousands of meters. We might be able to see the difference between the old solid, cold dikes and magma. And the new survey will be much higher resolution and would provide a much clearer view of these kinds of features, the dikes, lava flows, faults, and fractures, than this old survey. This is a picture from ground-based, very detailed resistivity data from the western part of the summit. And this view here is at about 150 meters depth. I just want to show you the red colors were interpreted as to be magma in Halimamau. And the right picture, that red blob, is magma. So we know that these kinds of data can image the sorts of things that we want to see. And for example, the magnetic data you can see the things like dikes, and the resistivity data with that will really tell the difference between, magma that's still hot and magma that's cold. Next slide. There was, along with that magnetic survey, there was a resistivity survey of the whole island, but it's very old. You couldn't get depth information. It gave us some general pictures, but one of the things that we could see are those green areas are very low resistivities near sea level. And so that's a place where seawater is underneath the island. And so we'll be able to get a much better picture of this kind of thing with our new data. Next. So these are depth slices from the Galapagos, another place that SkyTem has flown, that they're using it for to map fresh water supplies. So the top one's at the surface, the middle one is at 80 meters depth, so about 260 feet, and then the deeper one is at 525 feet. And the yellow and green colors on this map are showing where there's fresh water, and you can see how it changes as you get deeper. But then you also see the dark blues showing up at the coast in the deeper levels, and those are salt water. So these are the kinds of pictures we'll be able to see. Next one. The last slide is a cross section, which is how we often look at these data. So it'd be like looking at this wall with, as if it were depth. And this is from a really recent survey in Reunion Island, where you saw the helicopter flying. And it just shows the kinds of things that we can see. So all of those red colors on the top are very electrically resistive rocks. They're old. And then the blue and yellow, the bluish colors are where there is water. And in the bottom, they make a interpretation. The yellow is where there's shallow aquifers, and the blue lines show where there's groundwater. So it's just showing you that these are surveys that are used very commonly in these sorts of islands, generally speaking, for water, looking for fresh water. And the depth penetration for this kind of data is 2,000, 2,300 feet if it's very resistive, and shallower if we hit magma or water, it won't be as deep. Next. So what are the benefits of doing this kind of work? So the results of this project will help image shallow magma and groundwater pathways to the surface. There's still magma down here in this area. We don't know, and we'll be able to see that. We're also using it to inventory fresh water supplies and to detect shallow changes in the magmatic system since 1978. Next. Also, we're going to be, weather permitting and everything else, we'll be flying the summit crater on Monday. Not sure what time, sometime between 9 and 4, probably in the morning, but and several of us will be at different locations there to talk about the surveys more. So if you are interested, we'll be up there, and it will be interesting to see it flying in the crater. Next. So mahalo. We understand that helicopter noise can be disruptive, and we would greatly appreciate the affected residents' patience and understanding as we collect this data that's really critical to help mitigate future eruption hazards. And there's more information on these websites on the USGS. And I guess that's it. And any questions?
Yeah, we've got one from YouTube from Victoria who asked, how far down from the surface is magma detectable? Residential areas must benefit greatly from this knowledge. Is there an instrument you can use for this?
To do it in the residential areas? Well, we can't fly it. You can do it on the ground. But I think, well, I don't know, where's Fissure 8 relative, because we will be flying in the areas that were covered by. Right. Right there. That's what I thought. Yeah. So it'll be close. And we can see, so with the resistivity data, we can see in the upper 2,000 feet. And then with the magnetic data, we can see deeper, but it's not as reliable. Basically, be your way to develop there. Yeah. Yeah. They can, I mean, the helicopter is very agile. Um, yeah, I mean. You're flying over from the lead. Seeing, it's pretty much straight down. I mean, it's the footprints. Yeah, I mean the footprint's what, like 100 meters or so, and so we don't get like huge amounts of detail. We get good detail in the vertical resolution, but the footprint of the system is about 100 meters. So it's kind of integrating within that. So if you had something that was smaller than that, which wouldn't be probably that interesting anyway, you wouldn't see it.
We've got one more question. Are you guys going to be looking at the groundwater feeding into the Pāhoa tide pools and stuff like that?
Well, yeah, that's. I think we'll be. I'm not. See, since I'm not from here, right. I don't know exactly where that is relative to our flight lines. Yeah. So that's part of the thing. Is one of the reasons I showed that picture was because there's evidence that there's groundwater, right? It's coming out surface, and it'll help us.
I think it's important.
Yeah. It's kind of like, sort of like I mean, if you're thinking of a city, it's kind of like seeing the city water supply. I can't tell the difference. I mean, I can see the line coming into your house, but I can't tell the difference between your kitchen and your bathroom in terms of detail.
Is this going to be generated in some kind of map or something like that for public release?
Oh, yes. So we release all the data and the models, and we write papers, and there'll be communications through the USGS Science Communications Office in addition. And sometimes these kinds, like even if you write a scientific paper, sometimes they get a lot of press. And so then there's all of these articles written out by Newsweek or Wired Magazine or.
Flying the chopper to publication, what are you looking at in terms of timeline, just ballpark, year, 2 years?
Yeah, year, 2 years, something like that. I mean, we get the data a month to a few months after we fly, and it's to crank through this. We're pretty good at it now to crank through the data. Will take a while, but there's quality assurance that goes on every day. So we will see some of the preliminary data during the survey period. So
I do have one more asking for a little bit of clarification about, since Pāhoa and the areas that were basically covered in 2018 aren't showing us having time dedicated for them to be flown. When would they be flown? Just after everything else, or
the areas that were covered? Yeah.
Maybe that.
Yeah, we just can't fly over the houses. Yeah, all of that, all this, the coverage, everything that's covered is being flown by the flight lines.
Okay.
Yeah. Oh, these are good questions.
I think there's two different maps what they're looking at. There's this map, and then there's another map that stops around Kīlauea, showing
Well, yes, initially when they were designing the survey, the first maps that came, they had just taken the old residential areas that had streets on it, so they put a hole there, and so we since then I've told them so all of the areas that are covered are being flown.
Yeah, okay, I think that's it for us.
Oh,
Appreciate it very much.
well, thank you. I appreciate it. That worked out really well.
All right. Mahalo to you guys over there at Pāhoa Community Center for that awesome meeting from the USGS there. Mahalo to the USGS for sharing their time with us there. And so really appreciate that. And thank you guys who got your questions in. Victoria was the big winner there. Thank you guys for all your contributions. Thanks again to our sponsors. We'll be back as usual next week at our usual time, 5 p.m. Hawaiian time. And our more typical setup, right, with Dane up there where he usually is. But we thought this might be the best way to move forward today with this community meeting. So that said, I will, on behalf of Dane DuPont from HawaiiTracker.com, say aloha from him. And I am Philip Ong. And until next week, you guys, mahalo for your support. We'll see you guys.